Alright, so we're going to be graphing these two linear inequalities, and now this is called a compound because we have more than one, and this is the and, because I'm going to graph this one and this, and the solution is when do they both combined? Okay, it's the and statement. So when are they both true? And the next example, in example 3, we'll do the or case. All right, so let's go ahead and first solve for y right here. 6x minus 4y is less than 10, so I'm going to want to subtract 6 on both sides right here. All right, so cross that dude out. We have negative 4y is less than negative 6x plus 10. Now I want to solve for y, and so I'm going to divide by a negative 4. Do not forget that when we divide by a negative, we have to flip the inequality. So now this becomes y is greater than. Now I flipped that from negative to a greater than. Negative 6 divided by negative 4 is a positive 3 over 2. So 3 over 2x minus positive 10 divided by negative 4 is a minus 5 halves. Okay. And then we have our other guy right here, which is y is greater than 2. So here are the two that we're going to want to graph right now. Okay, so let's graph the first one right here. So we have a y-intercept of negative 5 halves. All right, so that's 2.5. So 1, 2, and then 0.5 right here. And we have a slope of 3 over 2, so up 3 over 2. So we're going to go up 3 over 2. Up 3 over 2. I'm going to make all my points here. Up. Oh, I'm sorry, I'm supposed to go up 1, 2. Supposed to be going up 3. I think I'm going only up 2 right there. So let me start that over again. So I'm going to go up 3. So 1, 2, 3 over 2. There we go. That looks better. Up 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Now you only need 2 points to make a line. I'm just doing this here so that means when I draw my little bar thing, it's nice and straight. Down 3 over 2. Down 3 over 2. All right, so that's the power of the slope, is that it gives you infinite many points going in either direction. All right, well, since it's greater than, and it has no line right here, then that means it's going to be a dashed line. So that's what I'm going to do now, is make my dash line not a solid but a dash line. Leave that guy right there, and I'll put an arrow just like that. So now let's do the shading. It's greater than, right? So my shading is going to be above, and so I'm not going to do a lot of shading. I'm just going to do a few yellow little stripes right here, and you'll see why, because I'm actually going to graph both of these, and then I want the combined. It's the and. When are they both true? So now let's graph y is greater than 2. And so again, that's a horizontal line at 2, right? At 1, 2, we have points that look like this. And the line is going to be a dash 1 as well. So we'll make that a dash line. Now the question is, do we shade above or below? Well, it's greater than, and greater than according to a rule up here is above. So I'm going to shade that one as well, but I'm going to do this in a different color. So I'm going to shade above like this. So the answer that we're looking for is when are both of these true. So this said and, right? In the beginning of our problem, we're looking for when they're both true. 6x minus 4y is less than 10 and y is greater than 2. So when are they both true? Well, you can see that they're both true right here. This is when they're both true. So really, this is the shaded region that we're looking for, and the rest of it, like out here and what we did over here, we actually want to erase this. And you say, well, what's the purpose of doing all that? So what happens is any coordinate point that you choose in this region will satisfy both the first inequality and the second inequality. Choose the point 0, 3. the point 1, 3, 1, 4, 1, 5. Choose the point negative 10, 6. If you plug them both in, you're going to get a true statement. And if you do it anywhere else, either one or both of them would be false. So this is kind of like a way of shading where all the solutions are true.